Hi, my name is Jack Gross, and this is my Python Markov name generator for CSC 380. Let's pick male or female, minimum name length, maximum name length, number of names, and the order. We'll do 3. It does some math, and it outputs names. These are all unique and novel. If we do it again, we get more names. Okay. So if we go, it's all in one Python file. At the bottom, we have the main logic here. We take a file name, read it into a name list, take that name list, read it into frequency data, which is the absolute number of times that characters follow other characters. We get the normalized data based off of that, which is the probability table. And then, given that probability table and a bunch of other parameters, we generate our name. So, we look in to get the frequency data. What we're doing is we're first creating an empty character dictionary, which is what I'm calling this nested dictionary where every level has an entry for every character. So you can do this, you can do a call like this, so dictionary A, or A, B, C, D for whatever character all the way to the end. And then it just sticks a 0 in there. And this is properly set up for whatever order your current model is in, which is passed in from here. So that creates levels all the way down for every character until the leaves where it sets in zeros. Now we take that big empty dictionary, or nested dictionary, and we iterate through this name, all the names that we get from the name list, and then we call add frequency data, or add to frequency data with a subslice of that name. And the way that we do that is we peel off the first letter of the substring and then subtract that from the substring and recursively call down. So that's getting us these keys for here. And then when the substring is only 1, then we're at we're at the leaf level. So then we just take whatever that leaf node is and add 1 to it. So this is counting up the number of times that character combinations occur. And that gets us our frequency data. Now we take that frequency data and we turn it into what I call normalized data, which is the probability table. So we're creating another empty character dictionary, which again is that nested multi-level dictionary with entries for every character set up for the order, and then the leaves start at 0. And we call normalized data row given the frequency data and the normalized data. This is all passed by reference, passed by reference because it's Python. So for every character and all the characters go through the frequency data and the normalized data. So this is going and subtract 1 from the order and call recursively. So this goes through every level, every entry in every level, and hits every row in that big giant dictionary. Then when the order is finally 0, we take our frequency data, sum up the whole row, avoid a division by 0, and then iterate again and set our normalized data to the frequency of that entry divided by the sum. And that gets us our probability. And this makes it row stochastic, so that the probability works correctly. So given that normalized data, now we can generate a name. We start with an initial prefix, which for me looks like these carets, and those are just sentinel values. And then we get a random character, and we keep going until the random character that we get is the end character, which for me is the greater than sign. So how are we getting these random characters? Again, recursively, we peel off the first letter in the subslice, and this subslice is the end of the word. If we look at where this is coming from, the last order letters in the name that's generated. So if the order is 4, it's the last 4 letters in the name. We pass that down and pass that down and keep peeling off letters until we get to the end, and then generate a random value. Keep adding up the probabilities until the sum of those probabilities is greater than that random value, and then we take that character and return it. And we keep doing that until the character that's returned is an end character. Then we take off the initial prefix, get the name, make sure it fits a bunch of parameters, and then return that name. And then that's just repeated a bunch of times, and then you can run it again.